I think I'm out, but back in. Yeah, that's exactly right. We would just need more examples. So what if I did a second example? Can we guess what the pattern is? No.
Oh. Okay, so David, they said they can see us now, but they don't see the presentation right now. But that's okay. We can share the presentation in a minute. Yeah.
It just kicked me out and I got back in for some reason, weirdly. Yeah, anybody else want to pipe in? And I'll just show you. Normally we would ask the students, instead of erasing these each time, yeah, there you go. Is there a way we could capture the counting that's happening? And we would arrive at something that looks like this. The students almost always say, yeah, make a table. So if this was our guesses, the sister said 1, the brother said 3, and then the sister said 2, brother said 6. What's the pattern? How does the brother know what to say? Oh, and you're going. Heather, that looks great. Cool.
Thank you.
Good. More confident that it's times 3, another times 3. Yeah, I totally agree. And at this point, we can say that, you know, the brother could be just making up random numbers, but it appears that we've identified a pattern. And if there's a pattern we can identify, we're going to call this a mathematical relationship. And in fact, algebra, a bunch of algebra really is about different kinds of mathematical relationships. And this one, this relationship where the brother is multiplying by a number, we call that has a name. That's called a ratio. In fact, you 7th graders learned that in 6th grade. And in 7th grade, we're going to call this a proportional relationship. And in the interest of not spending tons of time on this, we would show the students different ones that weren't proportional. We might show them a quadratic relationship or an exponential relationship. So there are different ones and they have different names. So what do we get out of this? One of the questions we can ask is, could we predict what the brother's going to say? So if the sister guessed 5, counted 5, could we predict what the brother's going to say? And I imagine that we could because we know.
Yeah. What do you all think it would be if the sister says 5? What do you think the brother will say? Thank you, Ellen.
Yeah. Yep.
Thank you, Mary Lou.
And we could go the other way. Could the sister, for example, could the sister trick the brother into saying 18 by counting the appropriate number?
What do you guys think? What would the sister have to say to trick the brother to say 18? Nice. Thanks, Kelly, Mary Lou.
Yeah, and those two things that we just did, predicting what the brother will say, the math word for that is evaluate, it turns out. And tricking the brother, in other words, what the sister would say to make the brother say something, that the math name for that is solve. And then I think maybe the last thing we'll do is, do you want to write down that sentence stem? Because something that students really struggle with is going from a numeric representation, a table like this, and writing an equation for it. So the way we scaffold that is to say, okay, could we complete the sentence, brother says, underscore?
Yep, and I will write that. Brother says, blank. How do we complete that? We're looking at orange. So we're looking for a rule to put inside that blank or the pattern that we see.
Yes, that is a really common response from students. Actually, another common response is they'll say, well, the brother says 6. And then I'll look back at the table and say, well, wait a minute. I think he's saying a whole bunch of things. And I think it kind of depends on something. So then they'll say things like times 3 or multiply by 3. And then
so David, say, well, check out Linnea's answer.
Nice. Yeah. So when the students say things like times 3 or multiply by 3, I'll say, well, can you say that more precisely? Multiply what by 3? And eventually we'll get to something that sounds like the brother says the sister times 3. Multiply the sister by 3. And having written that sentence, it's a fairly straightforward step to just go, well, in our table, B was a way to talk about brother. And I don't want to write brother every single time we do this. So I'm going to write B for brother, and I'm going to write S for sister. So the sentence that we just made from that stem just turned into the brother says S times 3. And instead of this being an actual verbalization using the word says, I'm going to say that mathematically, we're going to say that it's equal to. And we've found that progression really helps students start to write equations, thinking about what does the brother actually say? And then could I turn that sentence of a brother doing something into an algebraic equation?
Awesome, Amy. So glad that you find this helpful. Yeah, this will be really helpful as we watch a couple of video segments, because you'll hear David and I referring to the brother and sister story as a common story that the whole class is really familiar with. Brothers often don't talk to sisters readily, but that's okay. Nice.
Yeah, and I will say, middle school teachers, one, you may anticipate a problem that we've run into, which is we're using B in this case. In fact, right now, we could talk about independent and dependent variables, and the students very quickly pick up that the brother's number depends on the sister's. The problem is, as soon as we transition into something that like y equals mx plus b, that letter B means something really different. And I haven't resolved that yet. So it's not too bad going from brother and sister variables to x and y until you want to add that mx plus b. And now suddenly B totally changes meaning.
Yeah, and David, for people who are not math majors like me, I don't know if they caught what you just said, but they may have. But the S is the x-axis on a coordinate graph, and a B is the y, right?
Yep.
So we
and we talk about, that's a convention. If I was going to graph those as points, which we are all set up to do, we would need to decide like which is which is the across, which is the up and down. And we just talk about, well, the agreement is the independent variable, the sister's variable, is going to be the horizontal, it'd be the x-axis, and so on. And then we'll use this table to look at, what's the pattern going across? We just did that. This is a ×3 pattern, and that pattern has a name, proportional. We can also look up and down and ask, what is the sister counts by 1, what's the brother doing? And that turns into a conversation about unit rate, which is a really big idea in middle school math. Anyways, we like this story and this game because we can refer back to it over and over again. And you'll see us do that in some of the video clips.
Yeah, Linnea, that cat and dog and cat suggestion is something we'll have to consider. That's a good idea. I don't know if he already said it, but he has also considered saying why for younger brother.
Yeah.
Because I think part of the reason why is because sometimes when we adopt these stories and we start using them as teachers, repeatedly, now it's kind of like it's ingrained in us, like it's part of us. And it's kind of like, can I shift my brain now to a cat and a dog? Maybe, maybe I can. Maybe I'll keep reverting back to brother, sister. I don't know. But okay, we're going to go ahead and switch over again and go back to the big ideas, I think, right?
Yeah. Okay. So we're about to show our first video clip. And Heather, I forget, do you want to talk about this?
Okay, so I think we are going to go to the next slide actually, and talk about that a little bit before the video clip. Is that okay? Or
right.
You know what? We don't need to. We can do it afterwards because it'll probably be easier to do that way. Oh, okay, there we go. Okay, so stories to help students connect math to their lives. So for those of you who are familiar with GLAD, I took a process grid idea and I thought, how can I utilize this process grid idea to get students' voices involved and record their ideas so that I can launch the lesson each day, reviewing the concepts and content that we've talked about on previous days, but also utilizing students' connections with the math that they see in the world around them, and making a record of that so that we can see the progression over the course of the unit, and so that we can also add complexity to that chart as time goes by. So in GLAD, the process grid would be something that students would read things in a jigsaw type format, and then they would plug facts into that. So instead of using it for facts, we're using it to record some important information that we're teaching kids about math, but also the connections that they're making and the stories that they're seeing of the math that we're doing happening in the world around them. So you're going to see this procedure that we do with this chart in this video segment. It's about 6.5 minutes long. And as you are watching it, just think about that grid that we shared earlier, and about math being a social activity, about us coaching students to become independent thinkers about math and noticing math happening in the world around them and in their daily lives, and how engaged we see students being through this procedure. Please let us know if you can't hear it when he begins the video. So David, you're muted right now, and I can't hear it.
Okay, we can do that. I like it.
Can you rewind it really quick?
Yep.
Thank
do
you.
that chart relationship in your real life. Yeah. You forgot? Woo! Okay, we can do that. I like it. Okay, so do that chart, do that table on your whiteboard. Those of you at home, do it on a whiteboard or a paper. So Sienna said she has 3 dogs, and each one gets 3 scoops of food. Is that per day? Can we please make a table of that? While we're doing that, I'm going to put that on our sentence chart. What are you going to be paying attention to make sure that you're not favoring one dog over another as you're scooping up that food? So you'll be counting the scoops. And what else are you going to be doing as you're looking at the scoop? Like when you scoop up the food, making sure it's a full scoop, making sure it's not overfilled, maybe, right? Making sure it's fair. Okay, so that's the procedure, you guys, right? That's what she's going to be paying attention to. How would we say that? Yeah. Yeah, we got to fit it into our song. Count the scoops, same for each. Or actually, Mr. B, if we want to put in the word constant, and we have to make sure that every dog gets 3 scoops of food, could we say constant amount? Sure. Okay. And what is the operation we're talking about here? 3 dogs, 3 scoops of food. What operation do you see happening in your table? Okay, can we start? I like the way you guys started with 0. Can we put 1 after 0? So can we start with 1 dog? So after 0, 0, put 1. So 1 dog gets how many scoops? Vanessa. Oh, thank you for showing on your fingers. I love that. That is such a quick way to show me. Thank you. 1 dog gets 3 full scoops of food. Okay, that should be showing on your table. What about 2 dogs? Show me on your fingers. How many scoops of food will 2 dogs get? Those of you in the chat, please type it in the chat. How many scoops of food? If 1 dog gets 3 scoops, how many scoops of food will 2 dogs get? Oh, I love it. Thank you, Nolina, Noah, Tyler, Midge, Ayane. Oh, I love you guys. Okay, if you're showing me 6, you're correct. Okay, so your table so far looks like, remember we got sister, brother. So sister's going to be 0 dogs, 0 food. Then it's going to be 1 dog, 3 scoops of food. Per dog, there are 3 scoops, right? 2 dogs, 6 scoops of food. 3 dogs, how many scoops? Show me on your fingers. What are we doing each time? What operation's happening? Multiplying by 3. Thank you. Does anybody remember what is the name of that? What is the name of this kind of a chart? What kind of a relationship are we seeing in this chart? Yes, proportional. Thank you, Nolina. Thank you, Ayane. Okay, wonderful. How do we know that this is a proportional relationship? And then we're going to talk about the unit rate. Yeah, Sienna. Okay, tell me more about that. What do you mean? So every time we're multiplying by 3. And so do you guys remember what that's called? If the multiplier is the same each time, what's that word? Good. What is that? You remember, did you see that, Mr. Mead? I want to point something out to you. He remembered the action. He had to think about the word after he did the action.
Proportional, I did that.
You did. Excellent. Excellent. Yes. Okay, so let's say that together. Ready? And do our sign language. Ready? Constant multiplier. That means we're multiplying by the same number, like Sienna just pointed out to us, on each row. It's a constant multiplier. Everybody say that with me. Ready? Constant multiplier. Good. Let's do our little equation here. B is the number of scoops of food, right? The brother is calculating the scoops of food that he needs to give. And so 1 dog is 3 scoops. So I agree with Sienna. The brother is going to give the amount of food. It's going to be this the number of dogs the sister's counting times 3. So sister times 3 or 3s. E equals 3s. When we talk about a unit rate, everybody say unit rate. Unit rate. When we talk about a unit rate, we always have to have the word per, and we have to have something per something else. Okay? So right here is going to be food per dog. Okay, so how much are we jumping at? Because we're going to look at our vertical change. Every time the sister's number goes up 1, or we increase the dog by 1, how much does the brother's number or the food go up? Because that's going to be the unit rate. Yeah, thank you, Vanessa, for showing me.
Is that number changing each time? The brother is going up by 3. Is that staying the same or is that changing each time? Same. What's the word in math that means same? Constant. We have a constant rate of change.
Let's say that. Ready? Constant rate of change.
So we can look across and see if we have a constant multiplier. We can look up and down and see if we have a constant rate of change.
Yeah. So since this chart is has a constant multiplier, we know it is proportional because we look at the horizontal rows for that. Since it has a constant rate of change, what kind of relationship is that also? Since it has a constant rate of change, what is it? Linear. We're looking at notes right now. This is notes.
Yep.
Ready? Feeding the dogs in my living room, count the scoops, constant amount, multiply. Okay, I'm going to be asking you guys for another one next time. All right. Okay, I want to say something really quick. I don't know how small the screen was on your screen. It was pretty small on mine, but the story that happened the day before was about origami, and there was a student in that class who is an enthusiast about origami. He's created a dragon that's like 4 feet long out of a 8x8 paper that he worked on for months about origami. So I just want to point out that chart again is student stories each day that we're applying the math to. Will you type in the chat, what are your reactions to this? I've done this in 4th grade with the idea of area. I've done this in other grade levels with different content. What do you guys think about that use of that type of a chart?
I will share that I got to watch Heather's 5th graders sing several times, and she had been bugging me wanting to have my 7th graders sing. I finally relented and said, fine, you can have them sing. But I was thinking to myself, there's no way middle schoolers were singing. So I was astonished that the class sang along.
Awesome. Thank you for your responses. I am so sorry, Renee, that you're having trouble with sound. I don't know if I know Lynn is in here, Lynn Evans, for our support for our tech, I believe. And so I don't know, Lynn, if you might have some suggestion for Renee, who's having trouble with the sound. I'm sorry for that. Thank you all for your other ideas here. Yes, yes, they can make. Yes, Mary Lou, and you're going to see that happen, and some more stories that we're going to do in different ways. Absolutely, yes. Okay, thank you. All right, we're going to actually go ahead and do a song experience right now with you guys. Okay, so think about what we were saying about moving towards the red column and getting participants or our students involved in the course of the lesson. So we're going to actually look at a story embedded in a song right now. We were using about 5 different songs in that number relationships unit with the 7th graders, and this activity comes from their favorite song, the one that they preferred to sing over all the other ones. And I thought it was really interesting that they really liked this song, and that this song actually contains a story within the song about them learning math. And so so let's go ahead and look at that really quick. All right, I'm going to make it a little bigger. Okay, so you can see here a cloze activity, C-L-O-Z-E. So we have words to the song. We have some missing words where you see the blanks. I am going to write down your ideas of what words you think might fit there, so that we're going to co-create our own version of this verse really quick. And so it goes, just type in the chat first, though. We're going to see, yesterday when we presented, somebody was able to guess what song it was. Yeah, David put the question in the chat. Does anybody have an idea what song this might be based on? Yes, Mary Lou, absolutely. That's it.
That was fast.
That was fast. Yes, absolutely. Okay, so funny you're a young kid learning math on your board, blank blank and some blank. Okay, so type in the chat 3 words that you think would fit in those blanks. What could we put there? It could be anything math related. And David, if you'll help me, because in order for me to see the song frame, I have to like blow up that section so I can't see the chat. So okay. If you'll just help me, give me some words to write down for that.
Apparently.
All kids love Queen. I love Queen. Who doesn't love Queen? I remember being well, David was probably quite a bit older than me when Queen was really popular. But I remember being in elementary school when Queen was super popular, and like walking around with a boombox at recess and listening to them. Okay.
There we go. Adding, subtracting, and some story problems. Can you see that? You can't see those.
Well, I can't, you know what? It keeps on bouncing me around on my screen, and I keep having to reposition it. Okay, so I'm going to put adding, subtracting. Can you give me one more word that somebody wrote?
Story problems.
Okay. That I know that's going to totally wig you out with the cadence, David. Can you give me a different one? Yeah,
well, how about products, quotients, and addends?
Oh, okay. All right, I'll do that then. Products, quotients, and addends. Nice. Yeah, cadence is super important to David, you guys. Like, we get into spats during lessons like about that. So
I also like times, addition, cubes, and space.
Okay. I like that too. That's awesome. I went ahead and wrote down the products, quotients, and addends. Okay, let's go on to the next part. Got a mask on your face, distance your. What do you think would go there? What could go there? Are we getting any responses yet?
What was place?
Okay, I'll put it. Distance your place. Nice.
Somebody had a hilarious answer to that yesterday.
It was decimal place.
Oh, right. Yeah.
Yeah. Okay, and then writing your blank all over the place. What do you guys think? So what would these math students be writing down in this unit?
Math, answers, solutions.
Okay.
Doodle.
I'm gonna put answers. Okay. Okay, guys. So I know you can't hear me, or I can't hear you. Sorry, you can hear me. I can't hear you. But so I'm going to do this. I'm going to do this song for us with our words that we chose in this group. It's totally different from yesterday's version. You can feel free to sing along with me because we can't hear you if you'd like, but we wish we could. Okay, here we go. Funny, you're a young kid learning math on your board, products, quotients, and addends. Got a mask on your face, distance your place, writing your answers all over the place, singing number, relationships. All right, so that is an example of a collaborative type of activity that we could do that involves a story, a story about us learning math together. David mentioned like not really liking the idea of being told, just implement this SEL curriculum exactly as it is. You don't need to worry about it. It takes care of itself. This kind of thing of building class community, and having these kinds of shared experiences, this is also building social skills, right? We know that. Okay, so let's go ahead and continue on to our next slide. Oh, wait, go back to I'm sorry, David, go back to show them the actual version.
Yeah.
The kids. Yeah, just check out the version that the kids in the 7th grade class that we did together, if you're interested in that. And then David, if you actually, since we're probably not going to have time to do the next one, just show them the next slide too with the next stanza, because I think it's really funny. Just show them both versions. So they really like this one, actually. It goes, funny, you're a tall kid, a small kid, a bald kid. They love that. They love the bald kid part. So when they ask to sing the song, they always go, we want to sing the bald kid song. So it's like, okay, we're going to sing the bald kid song. All right, so let's go to the next one. Okay, so another way, we're moving on to a different grade level now. One of the grade levels that David and I worked with this past year as district coaches was 2nd grade. And we utilized, when we were talking about place value and working with place value and launching that unit with them, we talked to the 2nd grade teachers about, what has worked well in the past? What do these kids seem to be interested in? And Star Wars was a big interest in this particular class. A lot of them had their Baby Yoda stuffed animals and so forth. So we decided to equate the place value places with Star Wars characters from The Mandalorian. So we decided to utilize this idea of mind power. How much mind power did each of these characters have compared to the other one? And so droids, they need to be programmed. That's the one with the green background on the left. They need to be programmed by by people. They can't really think for themselves, but they can do things once they're programmed. So we called them 1s in terms of their mind power. The Mandalorian we called the 10 because, as you can see in the show, he can solve problems quickly. He has a lot of strategies that he can use. He's pretty smart. But Grogu, or Baby Yoda, he can move things with his mind. He can move huge creatures the size of elephants with his mind and huge things. So we called him a 100. And we had kids utilize those. We taught them how to do little simple sketches of those characters, and we had them utilize those ideas of values to create a symbol, symbolic numbers with those types of values, that kind of idea. David, did you want to add on to that?
Oh, I'll just mention a couple things. We didn't have to choose 10 and 100. We could have, if we had time, for example, say the Mandalorian is worth 2 droids. And now suddenly we're doing binary math. And I'll put into the link, this is actually really similar to the exploding dots work. There's this that James Tanton does. And he actually starts with binary math, and it's very intuitive, and the kids get it very quickly. And then as he goes, he builds up and then says, what if we did 10 to 1? And the way he's pitched it, it sounds like this crazy complicated jump to think, oh my gosh, each one is 10 times bigger. Until the kids realize, wait a minute, that's just our normal numbers. Like, oh, we've been building towards normal decimal numbers this whole time.
Yeah. So what David's referring to, if you're not familiar with exploding dots or the binary system, would be that every time that you get 2 in the 1s column, you switch it over and move it over to, it becomes like where you would typically have 10. And every time you get 2 in that column, you would move it over and it would become where you would typically have 100. It's a really interesting, we did that activity with students at several different grade levels this past year too. And it was really fascinating and interesting. Actually, David showed them also like carrying and borrowing with that system. So it just gets kids to think outside the box and think about about trading something in once you hit a certain number in that column and moving over to the next column. And they start to think really flexibly in that way, with other types of another system instead of a base 10 system. And it's really, really fascinating. It leads to some really flexible math thinking.
Yeah, and I guess I'm noticing we've never done banapples with students this young, second graders, but the same idea is also present, because we could ask them, what if I had 2 Mandalorians and 3 droids? I wanted to count them together. Would that make any sense? That gets weird. So
yeah, well, we did do it with third graders though, and they came up with some really interesting things. I think third graders were the first time that they ever told us items. If we had all these different things in the grocery cart, how could we add them together? And somebody came up with items. Okay. For those of you, I noticed we have quite a few third grade teachers and primary grade level teachers. We had at least one kindergarten teacher and some second grade teachers. What do you guys think about this? Would you ever consider, one thing I really liked about this experience we had with the second graders with this Star Wars idea was because of the high interest and it being 100% remote learning during that time, it was kind of hard to keep the kids engaged, in lessons online. And the kids during these lessons were really engaged. They had their stuffed animal out, they were showing us the screen, and they were really interested in talking about math and these values during this time because it was an interest they had. So would you guys ever try something like this, or do you think it would be, what do you guys think, for those of you who are primary teachers? Yeah, Kelly says yes.
Yeah, and I think stories that help students, make sense of math are good to use. Stories that students can kind of co-create with us are even better. And then I think the best ones are the ones not only that students had a hand in creating, but that we can refer back to throughout the school year or even the following school year.
Absolutely. All right, let's go ahead and move forward. We want to make sure we have time to do everything today. We got a little behind yesterday. All right, so we're on to what I consider the core of our work, what we've explored the most, and that is using stories to teach content and concepts. Nice, thank you, Liz. Yes, kiddos do love singing, absolutely. So we are going to show you some examples now at different grade levels of visual interactive math stories. So the idea of a visual interactive math story is to think of a story that's really relatable, for many people, and to couch the math within that story to have a general idea of the direction that we want the story to go. And the purpose of the story, though, in this case, is not actually the emphasis is not supporting the literacy. It's not supporting, that's not our purpose, is to our emphasis in this case, to emphasize like the characters or the events or how the story plays out. The emphasis is the math that we're teaching through the story. So the purpose of the story is to connect the experience of the students with the math. That's really the purpose. So we want a relatable story, and we want to either sketch it out while we're telling it to the students, or we want to have kind of like the flannel board idea where we have paper cutouts that we bring into the story as we tell the story. So we don't want to start with the visual already done. We want to it to unfold in front of the students. That's for brain imprinting, for them to feel like they're more part of the process and not just receiving that story, but actually part of the story. And then ideally we want to have parts of the story that are open, so that based on the ideas that the students give us, we can use their ideas in that story. So we don't necessarily need to have all of the details of the events of the story in place. We can have an idea of what we think is going to happen, but it's best if we leave it somewhat open to allow for student ideas to come into that story. So we're just going to show you a couple of examples. Oh, and usually the story is built around a math model of some sort. So it could be, in the second grade example you're about to see, it's going to be a domino model that they used in their math practice book. It could be a number line. You'll see a visual example of that. It could be an array, a clock. You'll see a clock example here. So whatever model the math practice that they're going to be doing is based around, typically that story will have some type of a visual model that it is unfolds on. Okay, let's go ahead and watch the second grade. $3 to eat. So she steps away And our next friend comes up to the counter and looks at what he wants to get. And he decides that he wants a burrito. So David, I'm not seeing the visual. Can you guys type in the chat? Are you seeing the visual, or I'm just hearing the audio?
Let me try again.
Okay, yeah. There we go. I see it now.
Oh, I see.
I think a burrito might cost. Just guess. See how much you think a burrito might be.
Yeah, could be. Williams thinks 6. Zoe 6. Siren 10. Johnny 4.
They're really good at predicting.
Johnny 5.
Nice.
5, Saliani.
Okay, if you said $6, you're right. The burrito does cost $6. And let me show you, instead of drawing the dollars, because you guys probably noticed that took a little bit of time for me to draw those, took a long time. So I'm gonna go ahead and do dots this time for my dollars instead. Okay, so instead of drawing dollar bills, I'm gonna draw dots, but these dots still mean dollars. So this is how many dollars this friend has. Show us on your fingers, how many dollars does this friend have to buy food? So you said 2, that our friend has $2. I totally agree with you. How many more dollars does our friend need to get up to the $6 to buy the burrito? Type that in the chat or show us on your fingers. How many more dots to draw over here on this side so we can get a total of $6? Okay, Mr. B, did you notice that? In the chat, William is estimating. He says 3 or 4.
We should try those.
Okay, let's try it. Okay,
Let's
so
try 3.
Let's try 3. Let's do it. Okay, so I'm going to draw 3. So let's count up our total dollars with our dots, since we know our dollars now. Let's count those up. Let's see if we get up to $6. Count them with me, everybody. Ready? 1, 2, 3, 4, 5. Did we get up to 6, everybody? If you think we got up to 6 by putting $3 on the side, put your thumb up. If you think maybe we didn't get to 6 yet, put your thumb down.
So how many dollars, if we started with 2, how many dollars do we need? How many more dollars?
To get up to our $6 that we need for our burrito.
I'm seeing some different answers. Nice.
One more. Thank you, Aviana. Thank you for clarifying. Okay, David, can you stop it? I totally agree. Thank you. All right. Do you have any thoughts about that? I just want to make sure we have enough time for everything we want to show. Okay, let's go ahead and watch the 5th grade one. And then if people have thoughts, the 5th grade one's about 3.5 minutes.
Hope I've got the right one.
It's the 3.5 minute one, the narrative, Hershey bar.
This one.
Yeah.
Okay.
You're watching to kind of help solidify what you're learning.
This is me. I'm sitting in my chair, relaxing after work. I've got my kitty, and I've got a Hershey bar. Type in the chat, what do you think would be a denominator that would make sense if I'm talking about this Hershey bar? Going, so horizontally 4, vertically 3, and we know that 4 times 3 is 12, right? So 12 would make sense as a denominator. If I ate the whole thing myself, how much would I eat? Can you tell me the fraction I would eat? Just as I was getting ready to pick up my Hershey bar and start eating it, here came my daughter, Texana. Hi, Mom. Type in the chat. What do you think she's going to say to me?
Make a prediction.
You're right, Gio. Gio got right in there.
Hand it over, Mom.
Good job, Sierra. What do each of us get now? What's the fraction each one of us will get? All of you who wrote either 6 out of 12, 6 pieces out of 12, or if you wrote 1/2, both of those would be correct because those fractions are equivalent. Everybody say equivalent. Equivalent. Doesn't matter if I break it up into the tiny little 12s and eat one at a time, and eat 6 of those tiny pieces, or if I just eat it all in one big gulp, the 1/2, I'm still going to eat the same amount of chocolate. Her dad came in. Guess what he said?
type your prediction in the chat.
Now, please type in the chat how much will each one of us get next. So if you said 4 out of 12, I totally agree with you because the row has 1, 2, 3, 4 little pieces along the bottom here horizontally. And we have 3 of those, right? So we could easily split it that way. And each one of us could get 1 row for 12, right? But also, if we wanted to just break it up into not the tiny pieces, but the long, skinny sticks, we would have 3 of those, right? So that means each one of us would get 1 out of 3 sticks. So we could break it into. Okay, but that wasn't where it stopped. What do you guys think happened next?
Anna said your son's gonna pop in on the set.
He wants some chocolate. Okay, now what fraction is everybody going to get? I totally agree with all of you who said everybody gets 1/4. I think if we break it up in columns this way that are vertical, we have 1, 2, 3, 4 columns and 4 people. So 1/4 is equivalent to 3/12. Let's all say that. Ready? 1/4 is equivalent or the same amount as 3 out of 12. 3/12. So Chris says, I think I may know who comes next, the grandparents. Yeah, good job, Chris. So how many total people do we have to give chocolate to? Because that will tell us our denominator. There's my chunk. There's Texano's chunk. There's my husband's chunk. There's Marshall's chunk. There's Garrett's chunk and Will's chunk, right? So count up the chunks. That's your denominator. So what is my fraction that I'm getting? 2 tiny sections out of a candy bar with 12 sections is the same amount as if I break up those 12 sections into 6 sections, 6 groups, and I only get 1 of those groups. So participants, I'm curious. I had to edit some things out, of course, of that video. Type in the chat if you have an idea. What are some other questions or predictions that you think the 5th graders made next and about that during that lesson? Does anybody have an idea? Here. Nice. Yes, Linnea, yes. Yes, they asked, did the cat want some chocolate? They absolutely did ask that. Yes. Yeah. Any other ideas of what they may have asked? Yeah, Kelly, good. So yes, somebody said, are we going to break it up into 100 pieces? Somebody did ask that. Very perceptive, yes. And actually, that would be something that I would wonder as well. Would they say, because there were 12 little sections in the original candy bar, would they say, aren't 12 people, total people going to come in to the story? So you can think about like how students are extending their thinking about the story, like what could happen next in relation to this math. Absolutely. Okay, we only have time to show you those 2 videos, but we wanted to show you a few more examples visually with some more pictures. So here's a hot cocoa story that's good for 4th grade, is an introduction to fractions of a number line on a number line. And this hot cocoa story the central problem is that I'm driving and I'm dancing in my car and I spill hot cocoa on my lap. And so what events happen after that? And so once the problem happens, it's very interactive because the students get a chance to suggest, how am I going to solve that problem? What events will happen? All right, next one.
Yeah, and I guess we're kind of thinking whether it's our story or the student's story, how are they invested in this? How are they participating in this story? And so they've, most of the things on that chart are things students came up with.
Yes, absolutely. And it's very engaging for them and they think it's funny, especially if it's around a funny thing. Here's a clock story that I've used with 2nd grade to introduce telling time on an analog clock, but I've also used it with 5th grade to talk about fractions of an hour and equivalent fractions. And so this one's about a cat. I found that students really like, as we've all seen probably during remote learning time, people like sharing their pets and pets are highly motivating a lot of times and engaging. And so this is about a cat. And again, there's flexibility in this story about what events happen around the clock, each 5-minute segment, what kind of adventures the cat gets into. If you're familiar with the Bad Kitty books, think about that idea. Like what adventures and trouble is the cat going to get into on this clock? Okay, go to the next one. Here's one that's called Rounding Town that I've used for several years, actually, to review rounding to the nearest 10, an idea of water coming up and getting high and getting into houses. So we need to row a boat to the closest high ground, which is on the 10s and the 100s. Okay, the next one. This is one that goes with an idea that David brought up in the big ideas slide when he was talking about seeing fractions as division stories. So David, did you want to talk about this one?
Yeah, this problem starts with me writing down 6 divided by 3, and the students can solve that very quickly. And then I tell them, I write down next to 6 divided by 3, 6 over 3, the fraction 6/3. And I ask the students, what is the name of that number? And it turns out they know it. They know that that's called 6/3. And so I tell them, okay, everyone, I'm claiming that 6 divided by 3 is the same thing as 6/3. And, you believe me or not, that's fine. I'm just claiming that that's true. And here's my question, everyone. And by the way, we've already established that 6 divided by 3 really represents 6 things shared with 3 people. So my question is, if that's true, how could a story about 6 things shared with 3 people turn into a story about thirds? And so we have them draw this, and I say, try it. Draw 6 things, share them with 3 people. And I want to know, I'm sure that you can do that. I want to know, where did thirds come from? And it's really hard. In fact, I've never seen a student do this. So then we stop and I say, okay, I would like you to do this exercise again. We're going to share this again, 6 things shared with 3 people, but with one change. I would like you to share these 6, let's say that's 6 cookies. I would like you to share them one at a time.
Well, in our story, we have pies in this visual. And, when we talk about the bakery, we actually show them, when we're drawing it out, we actually talk about the 3 people coming up with the money together, going into the bakery, taking the pie, bringing it out, dividing it equally, eating it, and then still being hungry and going back in the bakery. So it shows that what David was saying, pie by pie, one at a time.
Yeah, and the students get to see like, oh my gosh, suddenly thirds are happening. And they see, oh, after 1 pie, everybody gets 1/3. And they quickly realize that would mean after 6 pies, everybody gets 6/3. You can see their minds exploding.
Yes. All right, next one. This is the chart that goes with that lesson that we watched the beginning of with our, where we were talking about feeding the dogs. This is a unit rate chart that shows many different ways of measuring things. And so the next part of that lesson talked about a donut. And we talked about how are some different ways, referring to this chart or just different ways of thinking about a donut. What are some unit rates that we could come up with related to a donut? And students generated a lot of different scenarios about how to consider a donut. Like glaze per donut, bites per donut. Mr. B brought up, how many bites of the donut will my cat steal per donut? A student brought up measuring the dough. So weight per donut or per dough of donut, or volume of dough to use per donut, making donut. So it's just all of these are again, it's teacher initiated, teacher modeled for the first couple, and then the students start to get more and more involved in that discussion. All right, let's go to the next one. Okay, we made it to math procedures. Yesterday we didn't get this far, so we made it to this one. Awesome. Okay, so I'm guessing that many of you have stories that you use to help students remember steps in a procedure to do a calculation, maybe to help students remember how to multiply double digit times double digit numbers or do long division. Does anybody have math stories that you've used in the past? To type in the chat if you have a math story that you love, that you've come up with or you borrowed from someone else that you use to help students remember math procedures. The other day I went to the beach with some of my teacher friends and I was sharing with them what I was going to be sharing in this conference. And they gave me they said, oh, I have done Mary Lou says she has a story for regrouping. Nice. It seems like teachers, we collect our favorite stories through the years, or we make things up based on what we see students struggling with. Does anybody else have any other stories that you use for reinforcing math procedures or calculations? If there's more on the floor, go next door. Nice. Is that about rounding, Mary Lou? Or that? No, that's about regrouping. Nice. Kelly says converting measurements, horse to fly, multiply fly to horse, divided, of course. Oh, large to small and small to large. Nice. That is cool. Very cool. Nice. If anybody else has something that you want to share, please feel free. Type it in the chat. We would love to hear more ideas of how you've used stories, and especially in procedures in this section. Okay, so do you want to show, David, do you want to say anything about the slide, or do we just want to go to the next one?
Do you want to look at the video?
Yeah, I think I want to show the visuals first, because the video might make more sense if we show the visuals first.
Cool.
So the last video we're going to show is just a few minutes long, and it's from that same unit rate lesson, and it's when they're actually doing some calculations and simplifying algebraic expressions. Oh, division steps. Does McDonald's sell burgers? Nice. So what this slide you're seeing right now, the photograph, is of notes that we had students take during this unit on simplifying algebraic expressions with negative numbers. And so you'll see in the upper left hand corner, oh, nice, Linnea. Nice. That's awesome. They made it up. That's so cool. Wow, that's amazing. I love that. So you can see on the upper left corner, you can see that we've done a sketch of the piles and holes idea, that one pile of sand fills up exactly one hole in the ground where we took the sand out, with that idea of a positive one versus a negative one for one pile or one hole. You can see in the bottom left-hand corner, you can see a sketch of a brain, because we talk about with our students about metacognition, and we talk about how important it is for them to become liberated, for them to become independent thinkers in approaching the way that they solve problems and using tools that make sense to them. David, did you want to talk about how you don't think it's a good idea to do prescriptive steps or keep things standard all the time, and how we generated that list that they see in the bottom left corner?
Yeah, I guess I'll say, so that list on the lower left, it came out of originally some work as we were trying to use marking the text in different, from the ELA group, using it in different content areas. And to be honest, marking the text always feels a little bit forced when it comes to math. So I don't love it. This, though, came up from students and what we noticed students were struggling with. And so every time we saw something that students were struggling with, we would stop and go, what could we do right now that would make this easier? And it became a sort of marking the text. So we could start to use that language, which they knew from English and science and so forth. But now it was really directly useful to something we were trying to do.
Absolutely. Part of the procedure as well was the opposite monster, and that's in the upper right-hand corner of the notes in the green. And that is, David had shown the students that when there's a negative sign outside of a parenthesis, that means everything inside of the parenthesis is going to be opposite to what it is inside there. When he said that, when he was teaching them that, I just thought of this. I visualized, because I'm a very visual person, I visualized this monster, be kind of swooping over, or maybe like if you're a Harry Potter fan, like a Dementor or something, swooping over this parenthesis and changing everything to the opposite of what it was. So I coined that term opposite monster and just quickly sketched this little visual that you see there in the green of this with a negative sign turning into this monster. So when I taught them that, one of the students immediately said, that actually helps me. So the students adopted that phrase, that name, opposite monster, for that negative sign outside of the parenthesis. And then from that point on, that became a common story element a common understanding among that class, that we would talk about the opposite monster and what happens when there's a negative sign outside of the parenthesis. So these are just all examples of things to help students remember procedures and how to simplify or evaluate, whatever the word is, David, expressions to solve calculations. So we're going to go ahead and show a short video for that. I believe we're done at 2:55, so we've got a few more minutes.
I think I've got it roughly in the right spot.
Awesome.
They're changing when the sister changes by 1. Nice. Those of you in Zoom, you can type in the chat. How much is the brother changing when the sister changes by 1? Nice, Midge. Pretty sure you're still there.
Good.
Thank you, Lily. Thank you, Nolina, Ayana, Tyler.
Okay, unit rate. This is a unit rate of 3. Good. How about the other two? Oh, and I guess I should ask, is it always 3?
Nice job, Noah. Very insightful.
In other words, let's put this back in there. Every time I do this by 1, by 1, by 1, is this a 3, a 3, 3? Yes, so we have a constant unit rate.
Let's all say that. Ready? Constant unit rate.
Always.
Nice.
It's always going up 3 for 1.
So on this, somebody already said, I think you asked this, Mr. B. If you didn't, you're probably about to, right?
Yep, what's the unit rate on that?
Yeah, when the sister increases by 1 on this table, table 2, what's the change the brother's making? What's the unit rate? Show me on your fingers. Those of you in Zoom, type in the chat. Nice. How much is it changing from when we look at the vertical progression? 4 to 7. How much does it change? 13. Okay, good. If you're saying 3, you're absolutely right.
Yes. So, oh my gosh, this also has a unit rate of 3. So in some sense, so they have the same unit rate. Good. And I just want to point out that all proportional equations look like this. The brother is equal to some multiplier times the sister. Could be 3, could be -5, could be anything. As soon as we get away from that, we are no longer proportional. The equation was brother 3s plus, that's what we were using, 3s plus 4. So I want to know when the sister counts to -5, apparently she's counting backwards, which is fine. What did the brother say? What's the first thing you did, by the way? Find your answer. Like, what's the very first thing you did? James. Okay, we need to do -5 because I'm doing this, right? 3 times -5. There it is. What is 3 times -5? Be 3 -5, right? Which would be -15. Okay, so -15. Oh, here's the tricky part. -15 plus 4. Doesn't your brain just want to say that's -19?
Nope.
But this is, think of this as, is this piece piles or holes? The 15. 15 holes. And is the 4 piles or holes? And 4 piles. What happens when you put those together? I don't think we get 19 holes. Yeah. 4 of these fill up 4 of those. Leaving us with 11. But it's 11 holes. Okay, you're at -11? Nice.
All right. Our time is coming to an end. Shall we look back at that grid that we had earlier, David? So we can do a little reflection. Thank you, Matt, for your comment. Yes, absolutely. Oh, thank you, Linnea. Thank you guys for being here today. We really appreciate the opportunity to share. So just looking back at what this, oh, awesome. Thank you, Lynn. Yes. Yes, number rocket. Awesome. Thank you. Looking back at our grid again, just maybe reflecting a little bit about things that you've seen and examples. What are some things here that are moving us that you've seen and we've shared today that are moving us to the red column where we want to be with engaging students' ideas more in the class, with co-creating the class more with students than we've ever done before, so that they really are feeling like it's partly their creation as well, that they're taking ownership and that they feel engaged. And thank you, Mary Lou. Any other thoughts that anybody wants to share? Thank you, Kelly. Yeah, and I wanted to mention too, I thought that was so amazing what Linnea was telling us about her student creating that awesome chant or song. We also had a student who created a song about linear equations towards the end of the school year that was in this class that we were working with. And it's so awesome, you know, when they get to that point where they're starting to create materials for each other, and then we're using student materials. So awesome. Any other thoughts? David and I are still working together and collaborating. We're planning to continue to do that in an ongoing fashion. So we'll be continuing to explore this topic. And we're so excited that we got a chance to share our progress so far with you guys today. Thank you. David, did you want to say anything final?
I don't think so. Well, I'll be teaching math support for the first time in about 5 years. So we'll be taking some of these ideas into a support class for the first time this year.
Yeah, 6th grade support. Super excited. All right. Thank you, everybody. Thanks for being here today. Hope you have a great weekend.
Yeah, thanks, everyone.
Oh, Mary Lou wants to know if we can give them the slides. Can you email us? Oh, can you put up the email slide, David, by chance?
Yes.
You. Thank you for your great comments today and participation as well. Please email us, and because we have our slide presentation in a shared folder that's just with just 2 of us right now are in that parts of that folder or members of that folder. So I think it's harder for us to share it with you in that way, but we can send you a copy.
Yeah, I just need to get it to a place where I can share it outside of our district, which we can do.
Yeah, we can make a copy. Thank you so much, everyone.